let's look at another question here, and the question is question 16. The question reads, find the coordinates of the stationary points on the curve y is equals to x cubed minus 3x plus 2. Then for each stationary point, determine whether it is a minimum or maximum. Then the last part says, in the space provided, sketch the graph of the function y is equals to x cubed minus 3x plus 2. So what you're supposed to do here is that you have been told first to get the stationary points or the turning points of the curve. So you have been given the equation as y is equals to, that is calculus differentiation, x cubed minus 3x plus 2. Now how do you get the stationary points or the turning points of the curve, and how do you tell whether this is a minimum turning point or a maximum turning point, or how can you be able to explain the nature of these turning points of the curve, the nature of the turning points of the curve? If someone says determine the nature of the turning points of the curve, it's like actually asking you to determine whether these turning points are either minimum or maximum. So you first have to get what you call dy dx, or the gradient function. So how do I get the gradient function? I'm going to say let there be 1 here, and in this case I'm going to say the power times this, that is differentiating. So I'm going to get 3 times 1, then x, then reduce the power by what? By 1. So we're going to have squared, then minus, let me assume there is 1 here, so I'm going to say 3 times 1, that is actually 3 times 1, then that is x. So that means 1 minus 1, that gives you 0. So shall say x raised to 0. Then because these are constant, it gets dropped during differentiation. So what do I have as dy dx? Now my dy dx is going to be 3x squared minus 3. Great. 3x squared minus 3. Because 3 times 1 is 3. And x raised to 0 is 1. So I don't need even to write that. So my dy dx is this. Now how do I get the turning points of the curve? I'm supposed to pick 3x squared minus 3. Then I equate to 0. When I do that, I want to get the turning points of the curve, because the dy dx is 3x squared minus 3. And at any point, this must be able to give you 0. So in that case, that means that now, you're supposed to now to actually look for the common divisor. You're going to say 3 into, because this has to actually get factorized, you're going to get x squared minus 1. So this gives us 0. Now you actually say 3 is equals to 0. Then you can again say x squared minus 1 is equals to 0. This has to actually get dropped. And I'm coming here to have this. Let me factorize actually this by actually just saying a minus b, then a plus b. So the square root of x squared is actually x. The square root of 1 is 1. Then you can actually have the same expression but with a positive sign. You've actually factorized that. If I want to get the two values of x, I'm going to actually say x minus 1 is equals to 0. That means x is equals to 1 plus 0. So our first value of x is 1. And I'll say x plus 1, the second one, is equals to 0. So this is the first, then this is the second. Then I'm going to say x plus 1 is equals to 0. So x is equals to 0 minus 1. So x is equals to negative 1. So those are the values of x. And as far as the turning points of that curve are concerned, x is 1 and x is negative 1. Okay, so how do I get the corresponding values of y? I'm going to write here this equation. Y is equals to x cubed minus 3x plus 2. I just replace. So when x is 1, what is the value of y? So I'll say when x is 1, y will be, so I'll just say y, I'll bring this down, is equals to 1 cubed minus 3 into 1, because the values of x, then plus 2. So y is equals to 1 minus 3 plus 2. So y is equals to, obviously, 0. 1 minus 3 is negative 2. Negative 2 plus 2, that is 0. Now again I'll come here and say when x is negative 1, what will be the corresponding value of y? So when x is 1, y is 0. So I'll come here and write the equation down. Y is equals to x cubed minus 3x plus 2. So, and we've been told now the second x is negative 1. So we want to see what will be the value of y when x is negative 1. So it will be the value of y. So I'll come here and say y is equals to negative 1 cubed minus 3 into negative 1, then plus 2. So I'll have y is equals to negative 1. The negative number getting cubed gives you a negative number. The negative and negative will give you positive. Then plus 2. So y is equals to negative 1 plus 3 plus 2. That gives you 4. Good. So when x is 1, y is 0. When x is negative 1, y is 4. So when x is 1, let me now write the corresponding values of y, and of course they should be written in this order. So if x is 1, y is 0. So, and if x is negative 1, y is 4. So the turning points of the curve will be 1, 0, then negative 1, 4. Correct. Now we want to see the nature of these turning points of this curve, the nature of the turning points of the curve. How do I know whether this turning point is maximum or minimum? Good. This is what I'm supposed to do. So just have a look at this. I'll come here and say, I want to see, is 1, 0 the maximum turning point of the curve or the minimum turning point of the curve? If I can go to the next one, negative 1, 4. So I'll come here and draw something of this sort. I'll write here x, I'll write here dy, dx. Like that. We are trying to actually look at the nature of the turning points of the curve. Or is it a maximum turning point of the curve or a minimum turning point of the curve? Pick the value of x, which is 1. Write it in the middle. Okay? So that means if I have x here, I have the value as 1. Okay? And in this case, I have now the values of x getting written. So if I have x as 1, I'll write something less than 1, then something more than 1. So I actually pick at random any value that is actually less than 1. I write it on the left hand side of this one. I can say 0. Then here I can say 2. All can work. So I want to get the dy dx. Now our dy dx, as far as the equation was concerned, was actually this one here. Let me just show you. So we got our dy dx as 3x squared minus 3. dy dx, 3x squared minus 3. So we are supposed to actually have 3x squared minus 3 as our dy dx, 3x squared minus 3. So we shall replace. When you put here 0, so it will be 0 squared, that is 0. 0 times 3, 3 minus 3, that gives us what? So we shall have, let me just write it down here, 3x squared minus 3. That's the same as saying 3 into 0 squared minus 3. What is the answer? That is actually negative 3. Good. Okay. Then we shall come back here. Our x is 1, the one in the middle, so we shall put here 1. So we shall say 3 into 1 squared minus 3. 3 into 1 squared, that is actually 1 squared, which is 1 times 3, that is 3. 3 minus 3, the answer is 0. We shall write here 0. We shall come to 2. So we shall come here and say 3x squared minus 3. But now our value of x is 2. So this was 1, this was 0, this is actually 2. 1 was the one we picked from one of the turning points of the curve. Good. So we shall have 3 into 2, then squared minus 3. So that is the same as saying 3 into 4 minus 3. That is 12 minus 3, that gives us 9. So here is 9. Now look at this. When the value is negative, you have to do this. Decrease. If it is 0, it has to be actually at the peak. If it is positive, you have to draw something of this sort. So this is the same as having something of this case. Good. So this is negative, this is 0, and this is positive. Great. So that gives us what we call the minimum turning point. Good. The minimum turning point. The minimum turning point of the curve. So negative, it has to go like that, 0 like that, and then positive like that. So if you have to actually sketch this, it looks like that. Negative, 0, positive. So the minimum turning point of the curve. So 1, 0 is actually the minimum turning point of the curve. 1, 0. So let's go to the other pair.